A secant is a line that intersects a circle at 2 points. So a chord is a segment. So if you have a circle, a chord is a segment that connects 2 points. And a secant is a line that goes through with 2 points. And a tangent would be a line or segment that intersects a circle exactly once. So those are the differences among the three. So there's a few properties that when you have a secant, what can happen. So if you have two secants that intersect, the vertical angle in between them is half the sum of these two arcs. This is if it intersects inside the circle. If the two secants intersect outside the circle, these are all situations where it's outside the circle, you're going to take the outside arc minus the inside arc degree measure. So you subtract the bigger one minus the little one, you take half of it, and that's equal to angle 1. So these three just show the situations of where you could have both secants inside the circle, or you could have two secants, you could have one secant and one tangent, or you could have two tangents. So we're going to use these to do example 1. So this one is when you have two secants that intersect inside the circle. So you're going to have your x and your y, and it really doesn't matter which one's x and which one's y. This one you're going to take half of 46 and 90, because these are the outside arcs. So half the sum of the outside arcs is equal to the inside angle, which is x. So you do half of 136 and you get the measure of angle x equals 68 degrees. This one is a situation where you have a tangent and a secant, and they intersect outside the circle. So you're going to do where they intersect, so the angle 20, so 20 degrees is equal to 1/2. Now you're going to subtract the outside minus the inside. So it's going to be the outside minus the inside, which is z. So I multiply both sides by 2, so I get 40 equals 95 minus z. So the measure of angle z equals 50 degrees. The next one is these are both tangents. They intersect outside the circle. So when they intersect outside the circle, you subtract. So it's going to be 70 degrees, because that's where they intersect, is equal to 1/2 of the big one, which is w, minus 110. So you multiply both sides by 2 and get 140 equals w minus 110. So w equals 250 degrees. And then this one is, this angle is where they intersect, so angle y is equal to 1/2. They intersect on the outside, so you're going to subtract this one minus this one. So 110 minus 30, and you get 40 degrees. So the slide before, we were finding angle measures. Now this one is about lengths. So if you have two that intersect inside, on the same chord, A times B is equal to C times D. If both are secants, then you're going to use this property. So W plus X is times W equals Y plus Z times Y. And if you have a tangent and a secant, y plus z times y equals t squared. So you're going to have these on a formula sheet, so you'll have to recognize where to assign the letters. So number one is a situation. So I mean, this example right here matches up right here. So I'm going to go ahead and designate this inside to be x, this outside to be w. So it matches up right here. This inside to be z, and this inside or outside to be y. I know that this is a y right here, but I'm trying to follow along these letters right here. So then I write the formula, w plus x times w equals y plus z times y. And I substitute. I'm not going to substitute this y. This is actually z. So it's going to be 6 plus 8 times 6 equals 7 plus z times 7. And then it's just a matter of algebra to solve. So you get 84 equals 49 plus 7z, so then z equals 5. And for the second one over here, this is a secant and a tangent, so it matches up with this one. So even though there's a z that's outside right here, I'm going to call this t so I can use the formula. And this would be z, and this would be y. So I'm going to write the formula, y plus z times y equals t squared. So y is 8 plus 16 times 8 equals t squared. So this is going to be 192 equals t squared. So depending on if it tells you to round the nearest tenth or exact, you could break this down. This breaks down to 6√6. Okay, and then this next example looks like this one up here because you have two secants that intersect outside. We're talking about side lengths. So use this formula. W plus x times w equals y plus z times y. So I'm going to let this, the inside one is x, the outside one is w. The inside one is z, the outside one is y. So I'm going to use what I wrote in black when I substituted in. So it's 14 plus 20 times 14 equals 16 times 16 plus x. And you could solve for x, and you get x is 13.75. And then the last one is on the same chord, I'm going to multiply 6.5 times m and set it equal to, these two are on the same chord, 3 times 7. So it's 6.5 m equals 21, m equals 3.2.